So here's a follow-up on writing equations from lines. Again, this is part of a larger group of videos on how to write equations from a graph, a point and a slope, 2 points, or a data table. And we were looking at this, and we saw how to find the equation for the green line and the red line. The green line crossed at 2 and had a slope of 2/5, and so we said it was y equals 2/5 x plus 2, and the red line had a slope of negative 2/3, so it was negative 2/3 x, and then since it crosses at 7, it was plus 7, so y equals negative 2/3 x plus 7. But I kind of glossed over what about the horizontal line and the vertical line? What do you do with that? So I want to look at just specifically those things, and I want to take this one and just take this one and get it out of the way for right now, and I'll put it over here. I just want to look at this one. And you can think of this one as, it crosses at 7. I think, let's check that, 2, 4, 6. Yeah, it crosses at 7, and it's got a slope of 0. Okay, so you could write y equals 0x plus 7. Well, there's a perfectly reasonable equation. And of course, 0 times x is 0. Okay. Or we could just write y equals 7. Well, you remember, any equation like this is just a recipe for points. So if you have a recipe for points, it's got to work for all of them. What this is saying is, hey, every point you deal with on this line has a y that's equal to 7. Okay? Doesn't matter what x is, the y equals 7. So if I were to take that line and move it down to here, okay, now every y equals 2. We don't care what the x is. Every y is 2. And if it's down here, y is negative 1. If it's up here, y is 8. Okay? So anytime you've got a horizontal line, it's just y equals whatever number that is. Let's put it back here at 7, since that's what it was. 2, 4, 6, 7. So all of these are y equals 7. Okay? So let's bring this one back over here and put it right about, I don't know, here. Okay? Well, here's the way we're going to look at this. Okay? The blue one, right here, that equation, okay, describes this line. Okay? It says, hey, all the y's are 7. Well, on the purple one, the y's are now changing, aren't they? But notice that the x's are all the same. The x-coordinate here is 3, the x-coordinate there is 3, the x-coordinate there is 3. Regardless of what the y equals, the x equals 3. So that's what the equation is, x equals 3. If I move it to somewhere else, if I put it over here, now all the x's equal 5. Now all the x's equal 8. Now all the x's equal negative 1. So again, just like on lines that are neither horizontal nor vertical, that's called oblique, the equation describes the line. Here, all the y's equal 7, so y equals 7. Here, here, all the x's equal 3, so x equals 3. So when you get a horizontal line, okay, let me just get a graph going here. Okay. If I have a horizontal line at, say, 4, okay, we just say, look, the y equals 4. If the horizontal line happens to be at negative 6 down here, let's just put it negative 6, okay, then we'd say the equation is y equals negative 6. Okay? If instead you've got vertical lines, okay, you just look and say, let me change the color on that so it's, okay, if it's a vertical line, then no problem. You describe it with x equals a line. Okay, it looks like that would say 1. Okay, so it does get confusing sometimes for people because they say, wait. The x-axis is horizontal. So how could x equals 1 be vertical? Well, again, the x-axis is describing a number line, basically, and the x equals 1 equation is describing a line that's on the graph. They're different things. So when you're looking at horizontal or vertical lines, x equals a number is always a vertical line, even though the x-axis is horizontal, and y equals a number is always a horizontal line, even though the y-axis is vertical. So I like to think of it as, if I have y equals 4 right here, that says, hey, all the y coordinates are 4. So just make some points where the y coordinate's 4 and connect them with a line. Okay, that's horizontal and vertical lines.